Hi there. Welcome to Developing Progressive Apps, Responsive Design Part 3. Today we'll be looking at Flexbox. I'm Jasper. Right. If you want to code along, you are free to pause this video and follow the steps laid up in this setup. In addition, I've created a codepen that I'll be using in this lab just to demonstrate the principles or the examples I will be introducing. Otherwise, all that you need to know about the Flexbox you'll find out in this video. Let's now have a quick look on our starter files. First up, index.html. You see here we have an outer div with a class of container which contains 3 children with class of col for columns. And we have this meta viewport tag which we added in the first part of this lab. And moving on to our CSS, we see it targeting that outer container, giving it an overflow of auto, and the inner columns, giving them widths of 27% just to make them fit in one row. And we have this media query here, which we added in the last part, which is part 2, which rearranges the columns from 3 to 1 on device width of 48 rems and below. Right, going to our localhost 880, you see that we have 3 columns on wider width. As I resize, you see that it changes from 3 to 1 column because of that media query. Now I want to implement this same functionality but using Flexbox instead. Right, moving back to our main CSS, you'll notice that I've commented out all the rules. And if we check on our localhost 880, you see that the columns are now arranged in a single column and they are not rearranging themselves even as I resize. We are now going to look at how we can build this bit by bit using Flexbox. Now, establishing the Flex layout is one of the easiest things. It's just as easy as setting the display property to Flex or inline Flex. This allows the Flex items to participate in the Flex layout. Setting display Flex or inline Flex does 2 things, which are the container now becomes a Flex container and the direct children of the container now becomes Flex items. Flex or inline Flex doesn't change anything inside the Flex container. It will just act the same. It only affects the container. When you say display Flex, it's a block container, but when you say inline Flex, it's now an inline container. But otherwise, inside the container, things will just behave the same. There's no difference. Right, coming back to our main CSS, I will select the outer container and set the display property to Flex because we want our container to be a block container. If you wanted it to be inline, we have used inline Flex. And let's check on localhost 880 to see what has happened. You see now that the columns are now arranged in a single row, and when I resize down, they are not rearranging themselves or they are not wrapping. This is the default behavior of display Flex or inline Flex, which we'll discuss a bit later. But what happens is when you say display equals to Flex, it sets what we call the Flex direction to row and the Flex wrap to no wrap. But don't worry, at the moment we are going to go into what really these properties are. But just appreciate that by putting display Flex, automatically our container introduces a Flex context and the Flex items now participate in a Flex layout. Now let's have a quick look on Flex direction. You remember I said the default behavior when you set display property to Flex is that it sets the Flex direction to row. Right? This row it's affected by the writing mode, and in English is left to right. So our row will be from left to right. That's why we saw on localhost 880 that our columns were now arranged in a single row from left to right. But in languages, say in Japanese, their writing mode is from top to bottom. So their row will be from top to bottom. But what the flex direction does, it sets the main axis. That is, our main axis will be in the direction of the row if we set it to row. Say, for example, if we say flex direction is column, our main axis will be column. Okay? Two things. That is, it does either of the two things. Either it sets our main axis as a row, as you see here, or as a column, as you see here. The directions now are affected by the writing mode. And when you say row reverse, if you are in left to right writing modes, as in English, it means they will be arranged from right to left, and the row will be from left to right. If you are new to Flexbox layout, it may look a bit intimidating. I can assure you that it is very much easy if you get the grasp of it. So you need to shift your way of thinking. That is, stop to think about left or right, top or bottom, horizontal, vertical. But instead, when you are speaking of orientation, just think of two things: the main axis and the cross axis. And when it comes to direction, two things: start and end. We'll be saying main start, main end, or cross start, or cross end. Just that. To save your sanity, stop thinking in left, right, top, bottom, and all those things, because they will mess you up. Right? Just to hammer in, here's a diagram that will help to explain the terms that we'll be using in this lab. Right? You really need to understand this before moving on, so that you will not be confused. But I can assure you that when you get the grasp of this, Flexbox comes cheese and butter. The flex direction sets the main axis. So here I'm using this as an example, that our flex direction is set to row. Then you see our main axis is this one. Right? And instead of speaking of left to right, we'll be speaking of main start and main end. That's our direction. So we are moving from main start to main end. Okay? Our cross axis is perpendicular to the main axis. So this main axis was set by the flex direction, and our cross axis now is perpendicular to that. And instead of speaking of top and bottom, we'll be speaking of cross start, cross end. Right? And looking at our container, instead of speaking of vertical size or height, here we'll be speaking of cross size, because it is in the cross direction, this one. So this is cross size. And this, instead of speaking of width, we'll be speaking of main size, because it is in the main axis direction. Okay? Right? If flex direction is column, you see things have changed now. Our main axis is now this one. It has been set by flex direction. That is the one which determines the main axis, which is now this one, because we said our flex direction is column. And our cross axis is now this one, which is perpendicular to the main axis. Right? Our main size is now this one. Speaking of our container, the main size is now this one. We don't speak of height anymore, but it's the main size. And here our cross size is now this one. The same applies to our flex items. The cross size is now this one because it's in the cross dimension or in the cross axis direction. The same applies to the main size of the flex item is now this one because it's in the main axis. Right? So I encourage you to maybe rewind and take some break, rewind until you understand this thing. After this, you see that everything is just smooth flowing. Let's now have a look at FlexRep. As I alluded to earlier, the default is for the Flex container to set FlexRep to no rep. And this is what happens. The Flex items will overflow the container if their lengths along the main axis overflow the container. But if you set it to rep, the flip items will now rep. They will not overflow the container. And they will rep from the cross start direction to cross end direction. Remember, this is our main axis because our flex direction is raw, the default. Right? If you now set the flex rep to reverse, they're repping from cross end to cross start. That is along the cross axis. And these are called flex lines. It's very important to note this because we'll be using them in the future when you'll be doing alignment. In practice, you really need to use flex direction and flex rep as they are. Normally, you use the shorthand, which is flex flow, and you're encouraged to do that. So the first value here, in this example, the row is referring to flex direction and the rep is referring to flex rep. But you can also use it as flex flow and row only without the rep. And what it does, it will set the flex rep to the default, which is no rep. Right? I did a simple code pen to demonstrate the principles that I'll be introducing in this lab. It is just a simple unordered list with a class of flex container with 6 list items, which have class of flex item. I've done a bit of CSS on the list items just to make them visible. But at the moment, there's nothing Flexbox about it. It's just a simple unordered list. So let's now turn this into a Flexbox. Setting display flex. Our list items, they are now ordered in a row. You remember I said the default behavior is it says the flex direction to row and flex rep to no rep. If I try to resize the container here, you see that it's not repping, but it just overflows the container. So effectively, it is like this. Flex flow, row, and no rep. See that nothing changes. The same behavior. So that's the default behavior. Let's now set our flex rep to rep and see what happens. Come here and resize. When they don't fit in one row, they are now repping. And this is what we call the flex lines. So here we have 2 flex lines. Our main axis is in this direction, right? Because the flex direction is raw. Flex direction sets the main axis. So our main axis is in this direction because I'm using a left to right language. So our cross axis is perpendicular to the main axis. And our cross start is here. And cross end is here. So you see, when they are repping from cross start to cross end. They are forming cross lines. These cross lines, it's taking them from cross start to cross end. This is very important to know what is really happening here. Right, let's see what happens now if we set flex rep to rep reverse. I'll resize. See now? Previously, this 6 there was going down here, but now it is being stacked on top. What is happening here is rep reverse reverses the direction of the cross axis. You remember I said when it was only rep, start or cross start was here and the end was here. But when you say now rep reverse, the start is now here and the end is here. So always our lines, they are stacked from cross start, cross end. You see, there is nothing changing here. What has happened is the rep reverse has reversed our orientation. So instead of cross start being here and cross end being here, it's now cross start is now here and cross end is now here. Because of rep reverse, we have reversed the orientation. Right, let's see now what happens if we set our flex direction to row reverse. Right, as you can see here, our items are now arranged in the opposite direction from what we have seen earlier when it was just row. What is effectively happening here is row reverse changed the orientation of our main axis. It changed where the start is and the end is. When it was row, the main start was here and the main end was here. But when you say row reverse, it reverses the directions. Now our main start is now here and the main end is now here. Right? So our flex start will be here and the flex end is now here. So you see always it arranges the items from start to end, which is main start to main end. So if I resize, you see our 6 here is the first one to go because it's doing the same thing. So our cross start is here and cross end is here. So always items are arranged from start to end. Let us also see what happens if we make both row and rep to reverse. I think by now you can now work it out on your own what will be happening. In the main axis, which is this one, our flex start or main start is reversed. So it's starting from here and end is here. And we said always the items are arranged from start to end. So that's why we are seeing 1, 2, 3, 4 going from a start to end. Right? And our cross axis is this one. But since we have said reverse, it means now our cross start is here and cross end is here. So we expect that when we resize, our lines will be arranged from cross start going towards cross end, as you can see here. So our flex lines, they are arranged from cross start going towards cross end in this direction. Right, let's now have a brief look on what happens when we set our flex direction to column. It is similar and the same thing happening as we described. You only need to also reverse your mind so that you see what's happening here. So I've set the flex direction to column and the flex rep to rep. But as you can see here, these are now arranged in a column. And as we've been saying, items are always arranged from start to end. So since now our flex direction is column, it means now our main axis is in this direction, with main start here and main end at the bottom there. So our items, they are arranged from main start to main end. I have no way of reducing the height dynamically, so I'm just going to set it to say 300 pixels. And as you can see now, our items have wrapped, right? Since we said our main axis is this one, then our cross axis is this one. And cross start is here, and cross end is here. So like we said, items are always arranged from start to end. So our flex lines, they are being arranged from start going to end. If we say here reverse, right? See what has happened. We have reversed our cross axis. Our cross start is now here, and cross end is now here. And always items are arranged from start to end. So that's why you see it's wrapping our items from here, from start to end. Let's now have a quick look at a very important topic in Flexbox layout, and that is alignment. We have 4 properties that all use for alignment, and the first 3 here, that is justify content, align items, and align content, they are properties of the container. And align self, the last one, is a property of an individual flex item, right? Target here, it is referring to what is being aligned. So like here, say justify content is aligning items. The axis is referring to the axis along which the alignment is being done, which is either the main axis or the cross axis. And up here, there are the values which can be assigned to these properties on the left, right? So I will use smiling faces for values that are available for the particular property, and some crosses for those which are not available. So I'll start with justify content. The yellow smiley is the default. And when you say flex start, when we are in the main axis, is the same as we are saying main start. Remember that diagram I showed you before? Maybe you may need to go and recheck it. And we say flex end, it will be the same as main end. And sender will be the same as main sender. So the justify content is aligning items along the main axis. Align items aligns items, but in the cross axis, right? So here the flex start will be the same as cross start. Flex end will be saying cross end. Sender will be saying cross sender. And the default here is stretch, right? The align content, it again aligns along the cross axis, but it is now aligning flex lines rather than items. Remember, a flex line can contain one or more items. I remember previously I mentioned what flex lines are. When flex wrap is set to wrap or wrap reverse, flex items wrap into new lines whenever they do not fit on the current line. And these lines which are being created by flex items, they are called flex lines. So the align content align those flex lines. So it means when a flex line is being aligned, it moves with all the flex items that are within it. Then move on to align self. Align self is the same as align items, except that this align self is a property of a flex item, and it is used to override what will have been set on align items on an individual item. And the default is auto. Let's now have a quick look on alignment, and I'll start with justify content. Right, and here I've set the flex flow, that is the flex direction is raw and the flex wrap is wrap. Remember I said the default behavior of justify content is that it pegs items on flex start. And also justify content aligns items along the main axis. So since our flex direction is raw and we are using a left to right language, it means our main axis is stretching from here to there, right? So our flex start, which is synonymous in this situation to main start, is here. That is main start and the main end. So say the default is it aligns them on flex start. That's why you are seeing here they are pegged on FlexStart. Notice here that I've commented out the specify content. The default is in effect here. Let me now uncomment and see what happens. When justify content is FlexEnd, now our items, they are pegged or they are aligned on FlexEnd. You remember we said row reverse. It reverses the direction of our main axis. So let's just put it here and see what happens. You see now, our FlexStart, which is main start, is now here. And our main end is now here. Because of row reverse, we have reversed the direction of the main axis. Right? So FlexEnd is now this other side. Because of this row reverse, we have switched the start and the end. Right? Just to make it clear, let's change the FlexEnd here to FlexStart. Right? You see? It's now coming here. Because our main start or FlexStart is this and our end is this. Let's now change our justify content to sender and see what happens. Our items are centered along the main axis. This is for space between. You see it leaves equal spaces between items. And of note here is it flashes the first item on FlexStart and the last item on the main end, and it leaves equal spaces between the items. And this is for space around. It leaves an equal amount of space around each item. And you see here that is different from space between, because looking along the main size, you remember the main size of this item, the main size is in the main direction. So it leaves an equal amount of space along both sides of the main size. That's why you see here it's not flashing. And also here. But of note, you see that the spaces do not collapse. So here is double the amount of we see on the edge here. This is for space evenly. And you see it's similar to space around. But only the spaces between items, they collapse. So we have equal spaces even from the edges. Let's now move on to align items. Align items, it aligns along the cross axis. And since our main axis is this one, which is horizontal because of row, it means our cross axis stretches from here down to there because it is perpendicular to the main axis. And align items, it aligns items along this axis, right? And you say the default is stretch. If the height of the container is not given, it looks for an item with the greatest height. And looking at this number 5, you see it has the greatest height. So it stretches all the other containers to match that. But if the container's height was given, it will stretch to fill the height of the container. I think let me just demonstrate here. Say height is 300 pixels. It fills the container's height, even surpassing the height of our longest item. Right. Align items is now FlexStart. Our cross axis is running from here and end is down here. The items are now aligned on the cross start. If we say end, they are now aligned at the end. If we say center, they are now aligned at the center of the cross axis. If we look at flex lines, let me resize this one down first. You see what's happening. Each flex line is treated as an independent line. Cross start is here and cross end is here. Right? But on individual flex lines, which are these ones now, it aligns them on the center, and here on the next line, the lines again on the center. So it sort of treats the flex lines as independent entities. Right? While we are still at it, let us look at align self. Like I said, align self is the same as align items, except that align self is applied on the individual flex item. Here, align item is center. It's centering all the flex items along the cross axis. So let's change the item 6. Let's override it to FlexEnd instead. Right, you see now, item 6 is now aligned at flex end, and all the other ones which we have left, they are aligned at the center, which is this one. So align self overrides the values that have been put on flex items for that individual flex item. Let's now have a look at align content. I've set the flex container height of 500 pixels just to create some extra space on our flex lines as they are created, so that what we'll be doing here will be very apparent. And also I've left the align items at flex start. We don't want it to be the default, which is stretch, because it will sort of hide the things which we want to show here. The default of align content is stretch, as we learned earlier, and also that it aligns flex lines, not items. It is very important there. Align items, it aligns items, but align content, it aligns the flex lines. And now we are aware that flex lines, or a flex line, contains at least one flex item. So here, it's unfortunate that we can't see the line because it is imaginary. But what has happened here, since it is the default, it has stretched from flex start here to flex end. So it's stretching from top to bottom. But we are not seeing it because it's imaginary. But it's there, it's stretching from here down to there. That is the whole height of 500 pixels. Right. It's now align content is flex end. Our flex line was translated as it is, and it was aligned at flex end. Remember, align content also aligns along the cross axis. The same as align items, it aligns cross axis, but the difference is align items, it aligns items, whereas align content aligns flex lines. Right? So you see here, it has moved as it is to flex end. Right? I think just to demonstrate that, let me say here, align items, let me say flex end. Right? You see, the items now are the ones which are now aligned at the flex end due to the align items. You see? They are aligned using align items, which is aligning within the flex line. And the align content is aligning the whole flex line within the height which you have here, 500 pixels. Right? But here, let's return it to where it was. So if we say sender for content, you see, it's now on the center of the cross line, which has a height of 500 pixels. So align content, it aligns flex lines, and align items, it aligns flex items. Right? For space between, or actually when we are dealing with align content, it really applies when we have multiple flex lines. There it was a little hack that I did to put the 500 pixels so that I can demonstrate it just looking at one flex line. But in practice, it's used when there are multiple flex lines. So you see here, space between, the space here, between these two flex lines. So it will be flex between the flex lines, not between items. For flex around, see here, the same as we saw on justify content. The difference only that justify content was doing it along main axis and was doing it for flex items, whereas align content is doing it for flex lines and along the cross axis, but it's the same thing. For space evenly, right, in conclusion, let us just wrap up by applying all what we've learned and see if you can point out what is happening here. Justify content, align items, align content, and align self, they are all applied at the same time. Can you decode what is happening here? Right, here's my take. The justify content is flex start, and it aligns items along the main axis, and our main axis is this one. right? Because of row, which is the flex direction. Our main start is here and our main end is here. So if I say do this, you see that they are aligned at flex start. Okay, that's the justify content. And the align items aligns items along the cross axis, which is this one. The cross axis is that which is perpendicular to the main axis, right? And our main axis is this one, as we said, because of flex direction, which is row here. So align items is flex start. Our flex line, this one, is starting here and ending here, right, along the cross axis. So at flex start, you see that the items, they are aligned at flex start. That's why we are seeing it like this. And the align self, which is applied on the 6 here, is overriding align items and setting it to flex end. That's why the 6 is down here at the end rather than at the flex start here, right? And lastly, the align content is flex end. That is why we are seeing this line down here. This line, flex line, is stretching from here to here. And it is down here, leaving all this space. It's because of the 500 pixels that I have put in here. And it is on the flex end side. Right? So, flex start for the align content. If it was flex start, it was going to be on top there. Let's just do it. You see. Up to this point, we've been discussing properties that pertains to the main container or to the flex container, save only for align self. From this moment onwards, we'll be discussing properties that pertains to the flex items. Right, and the first one is order. Flex items, they are arranged in the order that they are arranged in the source order. As we look here, we have our items, item 1 to 6 arranged in this order. So the default is the flex items will be arranged in that source order, as we see here. But the order property can be used to change this ordering. But bear in mind that it will only change visually. But the HTML will still remain the same. The default of order is 0. So if you don't set it, it will be implicitly set to 0. So here, like item number 6, the order here is 0 because you didn't set it explicitly. So what order does is items are arranged in ascending order. That is, if you look at this example here, order 0, order number 1, order number 2, order 3, order 4. Right, and I want you to pay particular attention here. You see there's order 4 and order 4. But item number 1 is displayed first before item number 2. What happens is when the order values conflict or they are the same, it will fall back to the source order. You see here that item number 1 comes before item number 2. So that's why we see here item number 1 and item number 2. But pay particular attention that this is only for display purposes. Otherwise, assistive technologies that rely on reading the HTML will still be reading in that source order. Let's now have a look at flex factors. And this determines how the flex items grow or shrink to take advantage of the extra space available to them. We will first look at flex grow, which defaults to 0. It means they are not allowed to grow. Looking at this example here, we have these two flex items in this flex container, and we have this extra space which we call positive space in Flexbox terms. So these need to share this available space, and the flex grow is the ratios the space is going to be shared using. So here if we say flex grow is 2 and flex grow here is 1, it means this is going to take twice the space as this one. These are ratios, so we can say 200 and 100, still it will act the same. So it will be like this. This one has taken twice the space or has grown twice as fast as this one. When the flex items wrap, as we saw earlier, flex lines, they are treated as independent lines. So you see here, though we have flex grow of 1 for items 1 to 5, you will notice that items here which have wrapped to this new flex line, they are bigger than these ones. Yet they have the same flex grow value because each flex line is treated as an independent entity. Let's now look at flex shrink. This one is sort of the opposite of flex grow, but with a bit of a subtle difference there. Right, so here we have this container and these two flex items which don't fit into this container. So they must shed their extra length so that they can fit in this one. Right, and when you say flex shrink of 2 and flex shrink of 1, it means this one is going to shrink twice as fast as this one as they try to fit in this container. Right, so it will be like this. You see this one with 2 has shrunk twice as fast as this one. And when they wrap, the same thing applies. Flex lines are treated as independent entities. And here you can see that the default is 1. So by default, our flex items try to shrink to fit the available container. Let's now have a quick look on flex bases. This sets the initial main size of a flex item before the remaining space is distributed. You remember on flex factors, which I did previously, I sort of simplified the thing for easy understanding. And I simplified it in the way that I was assuming that flex basis is 0. That is, the available space was up for grabs from an initial size of 0. But most of the times you may need to set the flex basis so that the remaining space is distributed, taking into account that some items may have bigger content than the others. They don't necessarily not have to be the same size, but they must start somewhere and then share the available space. Right, when you say content, it is saying size me according to my content. You can also put the value of auto, which means look at my width or height property, depending on which one is along the main size. And you can also put the width value as pixels, rems, ems, etc. So the flex basis will be that width, and that width is first taken before space sharing is done. 0 means ignore my main size. In practice, you rarely need to use the longhand, that is flex grow, flex shrink, and flex basis. But there's a shorthand, which is flex. I've put a table that summarizes what it does. So we have several syntaxes: the 1 value syntax, the 2 value syntax, the 3 value syntax. And here I've put what will be the assumed values when you use these syntaxes. So the first one is when you say flex and then put a number, right, that number will be assumed to be the flex grow, and flex shrink is set to 1 and flex basis is set to 0. And initial, it assumes that flex grow is 0, flex shrink is 1, and flex basis is auto. This is the default. And flex auto, it says flex grow to 1, flex shrink to 1, and the flex basis to auto. That means it is allowed to grow and to shrink, and is taking into account its main size, which may be the width or height depending on the main axis. Flex none, it says both grow and shrink to 0, and flex basis to auto. It's not allowed to grow, neither can it shrink. It just remains at its given size. Right, then the 2 value syntax. When you say flex number and number here, that's number 1 and number 2. The first number is assumed to be flex grow, and the second number is assumed to be flex shrink. Right, and the flex basis of 0. When you put flex number and a width here, take note that this width must have a unit, say pixel, em, rem, etc. Then the number is taken to be flex grow, and flex shrink is taken to be 1. That is, it is allowed to shrink. And that width is taken to be the flex basis. When you put all the three values, that is number 1, number 2, and the width here, then number 1 is flex grow, number 2 is flex shrink, and the width is the flex basis. And you are encouraged to use this shorthand rather than the longhand, unless if you want to override what you have said previously. And of these syntaxes, 1 value, 2 value, 3 value, you are encouraged to use the 1 value syntax, unless situations are compelling that you should use these other two. Right, let's do a quick codepen demonstration on Flex. I've opened the pen, and what I want you to notice is I have 3 items here, which are our Flex items and this Flex container. The first item, I've given it a width of 300 pixels. The other two are not specified. So we are going to first look at flex basis. Here I've put flex 00 auto, and you know that this is flex grow and this is flex shrink, and the auto here is referring to flex basis. Auto means look at my size depending on the main axis, and here our main axis is row, because here we have row, so our main axis is in the row direction. Right. So it's saying look at my width. So here it comes to item number 1, and it checks and see that it says width is 300 pixels. So it says the 300 pixels here. But when it comes here, it cannot find a specified width. So what it does, it falls back to content size. That's why you see that it's just as big as the content, just to encompass the content. The same applies here. Let's now say flex basis is 100 pixels. You see what has happened. They set all the flex items width to 100. And of note here is, you see, even the 300 pixels that we've set here is also overridden, and 100 pixels is used here. So know that when you are dealing with flex boxes, the flex basis which you set will override all the other widths that you would have set. Let's look now on flex grow, which is here. So at the moment it is set as 0, which means it is not allowed to grow. Let's resize and see what happens. You see, it's just maintaining the initial sizes, and it's not growing to take advantage of the available space. Right? Let's now set our flex grow to 1 and see what happens. Right? And I resize. The items, they are growing to take advantage of the available space. You see that our flex item number 1 is the largest. This is because of the auto here. Auto says, look at my width in this case. So you see the width of 300 is far much bigger than the 2. First, before it shares the available space, it says 300 first here, and the width of this one and of that one also. So this one 300 is big. It started out being big already. Right? If I say here 0, so that they start all at 0, you see what happens. You see that they are the same sizes, irregardless of what's inside the flex item. They are the same sizes because they all begin at an equal footing of 0. Then space was just shared equally, since our grow here is 1. Just to re-emphasize, I've done a little bit of code change here, just to make what I'm trying to say to be apparent. So I've changed the font color to be black so that when it overflows it's seen. And also I've changed the min width of the flex item to 1 pixel. This is because by default flex items don't shrink less than their content width, but setting a lower min width here overrides that. I've made the content size of the last item to be very much big. And here still we have our flex 1 for all the items. And you know, using flex 1, it means our flex basis is 0. So they are starting from an equal footing. So you see that here, regardless of size, the flex items have the same size. And this one, which has long content size, still the flex item is of the same size and the content overflows the flex item. Now let's look at this scenario. You see here I've put 3 different flex grow sizes. And item number 1, which is this one, has the biggest flex grow. Right, followed by item number 2, and then this one is the least flex grow. And looking at it, you would think maybe there's a mistake, because we expected that this, which is a flex grow of 3, should be the biggest. But looking here, you see that the one with the least flex grow is the biggest. And I think by now you can decode what's happening here. Yes, it is because of this auto here. That is the flex basis. So it's saying, look at my size, and then after that, redistribute the remaining space. So this one has the biggest size because of this long content. So it started miles ahead, these ones. They didn't start at the same footing. It's not obvious that when he's put the greatest flex grow, it means that item will be big. It's not necessarily so. It depends on the flex basis. And this is the more natural way of doing it. Normally the items with the least content size is given the least flex grow, and that one with more content size is given the most. So this is more of the natural way. Let's now have a quick look on flex shrink. I have set the shrink factor of item number 1 to 1, of number 2 to 5, and of the third item to 10. Right, and I've also set the flex flow to raw, which is equivalent to raw and no wrap, because we don't want the wrapping to conceal our shrinking. Right, so I will resize. You can see that from this moment on, 3 is now shrinking very fast. For the same flex shrink factor, we expect that they shrink at a similar rate. And that's what you see here. They are shrinking at a similar rate. Let's consider this scenario. The shrink factors are still the same, but I've also added here the width. It is 50 pixels for item 1, 100 pixels for item 2, and 200 pixels for item 3. Let me resize. From this point, the third item has finished shrinking and is now constant. Right? And the other 2 are still shrinking. And from this point, the second item has stopped shrinking, it's now constant. And the first item is the last one to finish shrinking. What is happening is, to guard against a situation whereby smaller items like this 50 pixels comes to 0 before these other ones, which are bigger, even reduced significantly. What happens is, our shrink factor here, which is 1 for all the items, it is multiplied by the respective base width. It means now that here we'll be having a shrink factor of 50, and here a shrink factor of 100, and here a shrink factor of 200. This item will shrink faster than the others, and it's going to be restricted when it comes to its content width, because we didn't set the min width property, and the default is that items don't shrink beyond their content size. So this will shrink faster. This one will be a bit slower than this one, but faster than this other one. Armed with this knowledge, we now have what it takes to make our pages responsive using Flexbox. So here we just do a quick run, killing 2 birds with 1 stone. That is, we want to finish our lab and then make it progressive. That is, we give it some fallbacks for these other browsers which do not yet support the Flexbox. But all modern browsers, they support. But maybe may need to support also the older browsers. So we'll do it in one go here. So first, we put a modernizer file. So insert it here. This modernizer will check whether the browser supports Flexbox. And if it does, it just add a class of Flexbox to the HTML element. If it doesn't, it adds a class of no Flexbox. Right, in our main CSS, we replace this previous commented out CSS with the no Flexbox rules. And again, on this media query, these rules will form the fallback when Flexbox is not supported by the particular browser. Then we also replace this with the code that is run when the browser supports Flexbox. And going back to localhost 8080, you see that our page is now responsive as before, but here we are now using Flexbox. Right, in conclusion, here are the main points that you should take home. Flexbox is a one-dimensional layout method, but it can be nested to form complex layout methods, which surpasses other layout methods that precede it. It comprises of flex container and flex items. It lays items along the main axis and the cross axis. And the main axis is determined by the flex floor, and the cross axis is perpendicular to this main axis. Prefer using shorthand properties, that is flex floor and flex, rather than the longhand, unless if you want to override the properties that you have previously set. Use fallbacks for older browsers, because if it is not supported on that particular browser, then your layout will fail completely. So you should always provide a fallback. And thank you for watching.